Life in the early Jurassic through the eyes of Dimorphodon. In this episode, we would like to take you on a journey with one of the pterosaurs that lived in the early to mid-Jurassic period, dated between 200 to 161 million years ago. As we know, pterosaurs were flying archosaurs that are presumed to have been closely related to dinosaurs. There are two recognized species, Dimorphodon macronix and the Dimorphodon wentrabi. The creature has not been classified as a dinosaur, although it lived alongside them. The Dimorphodon is thought to have been closely related to the more well-known pterosaur, Pterodactylus. The adult Dimorphodon is believed to have been comparable to that of a large American crow, with an estimated body size of 1 meter or 3.3 feet. It was one of the largest pterosaurs of its time. Dimorphodon had a very notable, enormous, bulky skull, approximately 23 centimeters or 9.1 inches in length. The weight of the skull was reduced by large openings separated from each other by thin bony partitions. It is believed that it had a very small brain pan. Like birds, it probably had a large beak. The neck was short, strong and flexible, and it was lightened by air-filled sacs. It may have had a membranous pouch on the underside, but this is not confirmed. This reptile owes its name to its teeth of different sizes. Dimorphodon in Greek means two-formed tooth. The front ones were not only much larger, but also more pointed than the others. It had 4 or 5 fang-like teeth in the front of the upper jaw and 5 longer teeth in the lower jaw, whereas the teeth at the back of its lower jaw were tiny, although they were flattened and pointed, but shaped and sharp like lancets. Each jaw had a set of 30 to 40 teeth. The Dimorphodon had a wingspan of up to 1.5 meters, or about 5 feet. The wings were quite short in proportion to their robust body. Their clawed, very long and muscular legs were attached to the wings and had been used for catching prey and as a defense against enemies and predators. These claws, which were also on the hands, were strong and adapted to gripping onto cliffs, rocks, and tree branches. The powerful flight muscles were attached to a large breastbone and a large crest on the humerus. Preserved fossilized skin impressions show that the Dimorphodon had a covering of short, bristly feathers on its body and wing membranes. The thin membranes stretched from the 4th finger of each hand rearward to the hip or hind limbs. Dimorphodon was well suited for flapping flight. However, recent studies confirm that this pterosaur was rather a poor flyer. It is possible that it may have been able to fly using thermal or updrafts of warm air. Like some modern birds including fowls, tinamous and woodpeckers, Dimorphodon was probably able to make short flights. It had a long tail consisting of 30 vertebrae. The first 5 or 6 were short and flexible. The remainder gradually expanded towards the tip. The tail was stiffened by bony rods and probably helped stabilize it during flight. Most non-pterodactyloid pterosaurs, including Dimorphodon, were competent climbers. They possessed proportionally large and curved ungles and a low center of gravity. Some small-bodied climbers with sharp claws, such as modern squirrels, climb using a saltation locomotion. They use their forelegs and hind legs in alternate manner to hop up a tree. It is believed that this reptile probably walked on 2 legs. After landing, it would fold its wings in the manner of present-day birds and bats. The wing skin is gathered into wrinkled folds, and its flight fingers, especially the 3rd, back and up towards the side. This way, the wings did not obstruct walking, and the pterosaur didn't damage the membrane. Many artists represent this pterosaur in their illustrations with a puffin-like beak because of similarities between the two animals' skulls. In 1828, Mary Anning discovered the first Dimorphodon specimen in the Lim Regis on the south coast of England. The remains lacked the skull. This region of Britain has now been declared as a World Heritage Site and called the Jurassic Coast. The layers of the Blue Lace Formation are dated from the Entgian Sinomerian of the late Triassic to the early Jurassic. William Buckland bought the fossil and reported it in a meeting of the Geological Society on the 5th of February in 1829. A few years later, more thorough study was conducted by William Clift and William John Broderick, and the publication described and named the specimen as a new species. Buckland assigned the remains in the genus Pterodactylus and the new species Pterodactylus macronix. The specific name macronix is taken from Greek makros, meaning large, and onyx, translated as a claw, as an indication of the large claws of the hands. A piece of jaw was assigned by Buckland in 1835 to Pterodactylus macronix. It wasn't until 1858 when Richard Owen reported finding 2 new incomplete specimens. However, this time they included the skull. The scientists studied the skull and found it to be very different from that of Pterodactylus. Therefore, the remains of this reptile were given its own genus by Owen, named Dimorphodon. Initially, the remains were said to be a nomen nudum. By 1859, it was properly described, and in 1874, one of the specimens was made the holotype. More partial skeletons have been found over the years, mainly on the Dorset coast, although one of the fossil's remains comes from the Severn River, at the Oust Cliff. A partial skeleton was also recovered in siltstones from the site Chuzachal Canyon in the La Boca Formation in Tamaulipas, Mexico, from the early Jurassic Pliensbachian. It is believed the Dimorphodon also lived in Central and North America. The Dimorphodon was one of the first pterosaurs to be described. It is quite common that the classification of the bones causes a lot of problems and disagreements between scientists, and it was no exception regarding the Dimorphodon. The latest assignment shows that this animal is now with Pterosauria in the Macronychoptera clade and the family Dimorphodontidae. Little is known about how Dimorphodon lived. At that time, there were islands scattered across a shallow sea on the northern edge of the supercontinent Pangaea. Britain was between 30 and 40 degrees north of the equator, with annual temperatures of 12 to 29 degrees Celsius. Southern England formed part of a string of islands that stretched westwards into South Wales. Remains of Dimorphodon and related pterosaurs have been found in both seafloor and riverside woodland environments, and it shows the adaptation to living in a variety of different habitats. It may have lived in swampy or humid environments near rivers or lakes, similarly to modern-day bats, living on trees or roosting in caves. With its advanced jaw features, it could close extremely quickly with a light grip. The beak was well suited for eating insects, making Dimorphodon an insectivore, but it may have occasionally eaten small vertebrates like small fish, lizards, sphenodonts, and mammals. It is possible that it was an opportunistic eater, feeding on what was available, including some vegetation. Plesiosaurus. What did Dimorphodon see when it flew over the deep waters around the coastal areas? It is likely that this pterosaur observed some swimming hunters, such as Plesiosaurus. Although the first complete plesiosaur skeletons were found in England by Mary Anning in December 1923 in the Lias group, some earlier records reported partial skeletons of this creature. Scientists had never seen anything like it before, and it was a big puzzle for them at the time. The name was given by Delabèche and Conybeare in 1821. Plesiosaurus's name was taken from Greek, plesios meaning near or close to, and saurus meaning lizard, together meaning almost a lizard. As it was the first of these plesiosaurs to have been described, its name became the name of the whole group. But also, since its discovery, any similar remains that have been found were assigned to the Plesiosaurus wastebasket taxon. Fossils of belemnites, the squid-like animals, and ammonites, including the great nautilus-like mollusks, have been found within the remains of Plesiosaurus. It was able to hunt fish with its powerful jaws and long and sharp teeth interlocking its prey. It possibly used its long neck to move their head into position to catch unaware fish or cephalopods. Osteothires, bony fish, were in abundance in the Jurassic. Researchers think that plesiosaurs may have been bottom feeders too. It is believed that the gastroliths that have been found in plesiosaurus stomachs helped them to break down food, and possibly with adjusting its buoyancy. Could Dimorphodon have become their food? Well, if not careful. For example, when it landed on a water surface, it is possible that it could be snatched by any aquatic predator, including Plesiosaurus. These marine animals were also opportunists, therefore could scavenge on floating corpses. Buckland, who studied the species, said about this animal that they were a snake threaded through the body of a turtle. The skull was small, and it had a very long neck, containing 40 cervical vertebrae, on almost half as long as its body. The flippers were once legs in its ancestors, and were quite stiff. Each paddle had toes with many more bones than that found in a tetrapod. It is believed that they were good for paddling, but not helpful on the land. Plesiosaurus was probably capable of pulling its body with the frontal flippers and pushing the body with the rear. It is likely that it stayed close to the water banks rather than going far inland. So how did it swim? Scientists think that it swam by using a flying action, similar to a modern penguin or sea lion, using its rear paddles for power with the downward stroke, whereas the front paddles were used mainly for balance and for maneuverability. It is thought that Plesiosaurus was a slow swimmer. These animals were air-breathing reptiles and must have come to the surface frequently. They probably swam just below the waterline and could have dived for food for limited periods of time. The body was quite solid and compact, reaching about 3.5 meters or 11 feet in length. They lived from the Triassic to the Cretaceous periods and were the largest aquatic animals of their time. Previous study suggested that plesiosaurs may have crawled onto a beach to lay their eggs in the sand, just like the modern leatherback turtle, although it could have potentially attracted terrestrial predators. The young would also have to be taken back to the sea, and the animal would have to rely on the tides. However, they are now leaning towards a theory that plesiosaurs gave birth to live young, like some other marine reptiles. Many museums all over the world have plesiosaur specimens in their collection. The Natural History Museum of London has on display the skeleton found by Mary Anning. A very interesting specimen of the pregnant Plesiosaurus can be seen in the Natural History Museum in Los Angeles. According to the museum's website, it is the only pregnant plesiosaur fossil ever discovered. The Dimorphodon's eyes were large and round, giving it excellent vision both in the air and on the ground. The binocular vision would have been helpful when hunting. More studies are needed to establish whether pterosaurs like Dimorphodon grabbed their prey while on the wing or while standing on all fours, like other pterosaurs. The Dimorphodon probably had good eyesight and hearing, which helped it to locate its prey and avoid obstacles on the way while flying. Although it was not very agile on the ground, it would have been able to fly swiftly and gracefully through the air. It is also thought that the Dimorphodon may have been semi-aquatic and able to land on water as well as on land. Scientists think that because it fed on fish, it had waterproof fur. Scelidosaurus. In the early Jurassic, many new groups of dinosaurs began to emerge. While searching for food in woodlands, Dimorphodon may have seen Scelidosaurus, with which it shared the environment. It is characterized by the presence of armor on their backs. Over the years, a number of specimens of Scelidosaurus have been found along the Jurassic coast between Charmouth and Lim Regis in the Black Vens Cliffs of the Charmouth Mudstone Formation and North America. It is thought the species lived between 190.8 and 182.7 million years ago. The animal was typically about 3 to 4 meters or 13 feet long. It had a relatively small head in proportion to its body size. The skull had horny scutes on its back edge. Scientists confirmed that it also had several bones that have never been seen before in any other dinosaur. Its teeth were small and in the front of the upper jaw. These teeth were not suitable for chewing, but to bite up and down, slicing and crushing the soft flowers of palm-like plants. Scelidosaurus is thought to be a quadrupedal herbivorous dinosaur. Its front limbs were shorter than the hind limbs. The feet were long and had toes, with hoof-like sharp claws on their tips. It is possible that the animal was able to stand on its rear legs for a short period of time, to reach to the higher vegetation or when in a hurry. Scelidosaurus belonged to the bird-hipped dinosaurs, the ornithischians. It had protective covering in the form of varied in shape bony scutes or osteoderms in rows on the side and back. The tail was long, narrow and armored. If a theropod tried to bite Scelidosaurus, it is likely their teeth would crunch. Its tail vertebra was studied to see if the animal was a marine creature. However, it was assessed as insufficient for this shield-bearer to have been a strong swimmer, and it was confirmed that Scelidosaurus was a terrestrial dinosaur. Due to the heavy armor, Scelidosaurus would probably have been a rather slow-moving dinosaur, although it was ample to defend from attacks by Jurassic theropods. The starter with the remains that had been found to mainly contain marine fossils. However, fossils of land-living plants and animals, such as wood and flies, mixed with aquatic ammonites in the same layers, also have been found. Researchers discovered similar fossilized vegetable contents present in Scelidosaurus' specimen's stomach. They likened these skin impressions to those of a crocodile on account of the pattern and osteoderms. Scelidosaurus was initially seen as an early member of the Stegosauridae, including dinosaurs such as Stegosaurus. After more study of the anatomy of Scelidosaurus, it is now considered as an ancestor of the Ankylosaurus. Soft tissues are rare to find. It is believed that the preservation of it in the fossils is evidence for rapid burial of the individual in the marine sediment caused by a higher energy water flow, such as periodic flooding in the area. The floods would have washed some dinosaurs into the sea where they drowned, then were buried and eventually fossilized. Dimorphodon seemed to be either too fast or too big to be taken down by most dinosaurs. The animal had to be aware of crocodiles that could easily snap them up. Even when flying above the water, there were many marine reptiles like Plesiosaurus, Mosasaurus, or Ichthyosaurus that would happily snatch Dimorphodon for its lunch. It is believed that their main predator was the Dilophosaurus. Dimorphodon could also become prey of other predators, such as Sarcosaurus, which was a genus very similar to Dilophosaurus. This theropod was a light, agile, and bipedal carnivore. It was roughly 3.5 meters or 11 feet long, with an estimated weight around 50 to 60 kilograms. Although larger individual skeletons reach a maximum length of 5 meters and a weight of up to 140 kilograms, have also been found. It lived in what is now England during the Haintian-Sinomerian stages of the early Jurassic, about 199 to 194 million years ago. Sarcosaurus is one of the earliest known Jurassic theropods, and one of only a handful of theropod genera from this time period, along with Dracoraptor hanagani, which we have already covered in the episode called Early Jurassic Dinosaurs. It is one of the two described basal neotheropods from the lower Jurassic of the United Kingdom. Very little is known about Sarcosaurus. All specimens contain partial skeletons, like a partial pelvis, a femur, and some vertebrae. No skull material was ever found for this genus of dinosaur. Some artists present this theropod with the crest on the skull, which is only pure guesswork. It is probably due to some carnivorous dinosaurs that possess such ornamentation. It is likely that Sarcosaurus lived by the sea, and its corpse was washed out to the sea after heavy rain or flooding. The state of the bones found show that it was not a juvenile, although it is difficult to establish what age the animal was at the time of its death. Sarcosaurus shares certain morphological conditions with other neotheropods, including Liliensternus liliensterni and Dilophosaurus witherili, but also with the later Ceratosaurus. Some scientists actually think that it was an early species of that genus. Classification of this dinosaur was very confusing. Initially, it was assigned to the Megalosauridae, then to the Ceratosauridae, to be later classified to the Coelophysidae. The fossils of Sarcosaurus were found in the Lower Lias in Warwickshire of England, which is known as the Marine Strata. These Lias beds contain layers of rocks that alternate between shale and limestone. The type species, Sarcosaurus woodi, was first described by Charles William Andrews in 1921. The generic name is made of the Greek word sarx, translated as flesh. Therefore, the name meaning is a flesh-eating lizard. The specific name was given in honor of Wood, who found a partial skeleton in 1921 near Barrow-on-Soar in the Scunthorpe Mudstone. A second species, Sarcosaurus andrewsi, was also from the early Jurassic period in England, but only one isolated femur was found. The reproduction process of Dimorphodon is still unknown. However, scientists believe that the species laid their eggs in nests built on cliffs or trees. The female would have carefully selected the right nesting site for digging a hole and laying her eggs. As soon as the eggs were laid, they would be covered with some leaves and sand for protection from predators or the natural elements. It is thought that the incubation period for Dimorphodon eggs would have taken around 60 days. The feeding of babies would likely involve spitting up already eaten food right into their mouths. The hatchlings would be cared for by their parents until they were old enough to live on their own. But why did these flying reptiles go extinct? Scientists believed that it happened because they could not compete with the larger dinosaurs for food and due to changes in the climate. These videos take a very long time to create. If you would like to support the channel and assist in improving it, then do please subscribe and give us a like, and consider joining our Patreon, links in the description.